In 1971, heavy rain fell across much of east Nebraska. In the summer, paleontologist Mike Voorhees traveled to the farmland around the Midwest town of Orchard. What he was to discover exceeded his wildest dreams. It was a site of sudden prehistoric disaster. Voorhees' digging revealed the bones of 200 fossilized rhinos, together with the prehistoric skeletons of camels and lizards, horses and turtles. Dating showed they had all died abruptly 10 million years ago.
It suddenly dawned on me that this was a scene of a mass catastrophe of a type that I'd never encountered before.
The cause of death, however, remained a mystery. It was not from old age.
I could tell by looking at the teeth that these animals had. Astounding was that here were young mothers and their babies, big bull rhinos in the prime of life, and here they were dead for no apparent reason.
For the animals at Orchard, death had come suddenly. There was another strange feature to the skeletons, an oddity which offered a crucial clue about the cause of the catastrophe.
We saw that all of these skeletons were covered with very peculiar growth, soft material that I first thought was a mineral deposit. Then we noticed that it was cellular. It's biological in origin, so there was something actually growing on those bones. I had no idea what that stuff was, never seen anything like it.
A paleopathologist, Carl Reinhard, was sent a sample of the bones.
This specimen is typical of the rhino bones. You see this material, in this case it's a whitish material that's deposited on the surface of the original bone. This was peculiar to me, but as I thought back in my experience, I realized that this was similar to something that turns up in the veterinary world, a disease called Marie's disease.
Marie's is a symptom of deadly lung disease. Every animal at Orchard seemed to be infected.
But one of the clues was that all of the animals had it. Now that is a very important observation. For all of the diseases, or all the animals to exhibit this disease, there had to be some universal problem.
Scientists discovered the universal problem was ash. 10 million years ago, ash had choked them to death.
It may have been a bit like pneumonia with the lungs filling with fluid, except in this case the fluid would have been blood, for the ash is very sharp. There'd be microscopic shards of ash lacerating the lung tissue and causing the bleeding. I imagine these animals as stumbling around the thick ash, spitting up blood through their mouths and gradually dying in a most miserable way.
Only a volcano could have produced so much ash. Yet the wide, flat plains of Nebraska have no volcanoes.
I remember some of my students and I sitting around after a day's digging and just speculating, where did this stuff come from? There are no volcanoes in Nebraska now. As far as we know, there never have been. We obviously had to have a volcano somewhere that produced enough ash to completely drown the landscape here. But where that was really was anybody's guess.
One geologist in Idaho realized there had been a volcanic eruption, which coincided with the disaster at Orchard 10 million years ago. but the site was halfway across North America.
It seemed like a really fascinating story, which made me think, because I had been working on volcanic rocks in southwestern Idaho that potentially could make lots of ash, and there were some age dates on that were around 10 million years. And I began to wonder, wow, could this situation in Nebraska have really been caused by some of these large eruptions that evidently had happened in southwestern Idaho?
The extinct volcanic area, Bruno Jar Bridge, was 1,600 kilometers away, a vast distance. How could this eruption have blasted so much ash so far? Bonnickson was skeptical.
Volcanoes will spew ash for a few tens or maybe a few hundreds of miles. This ash, and it's like 2 meters thick, in Nebraska is 1,600 kilometers or more away from its potential source. So that's an amazing thing. There really had been no previous documentation, to my knowledge, of a phenomenon like that.
Despite his doubts, Bonnickson decided to compare the chemical content of ash from the two sites. He analyzed samples from both Bruno Jar Bridge and Orchard and plotted their mineral composition on a graph, looking for similarities.
If you have a group of rocks that are very similar to one another, they should be a closely spaced cluster of points. We had these analyses come out from the Orchard site, and I thought I'd try the plot again and see how close they were to one another. By golly, they fall right in the same little trend as the Bruno Jar Bridge samples.
Bonnickson's hunch had proved correct. Bruno Jar Bridge was responsible for the catastrophe at Orchard. An eruption covering half of North America with 2 meters of ash was hundreds of times more powerful than any normal volcano. It seemed almost unbelievable. But then Bruno Jar Bridge was that rarest of phenomena which scientists barely understand and the public knows nothing about: a supervolcano.
Supervolcanoes are eruptions and explosions of catastrophic proportions.
When you actually sit down and think about these things, they are absolutely apocalyptic in scale.
It's difficult to conceive of an eruption this big.
Scientists have never witnessed a supervolcanic eruption, but they can calculate how vast they are.
Super eruptions are often called VEI8 eruptions, and this means that they sit at 0.8 on what's known as the volcano explosivity index. Now, this runs from 0 up to 8. It's actually a measure of the violence of a volcanic eruption, and each point on it represents an eruption 10 times more powerful than the previous one. So if we take Mount St. Helens, for example, which is a VEI5, we can represent that eruption by a cube of this sort of size. This represents the amount of material ejected during that eruption. If we go one step higher and look at a VEI6, something of the Santorini size, for example, then we can represent the amount of material ejected in Santorini by a cube of this sort of size. But if we go up to VEI8 eruptions, then we're dealing with something on an altogether different scale, a colossal eruption. And you can represent a VEI8, some of the biggest VEI8 eruptions, by a cube of this sort of size. It's absolutely enormous.
Normal volcanoes are formed by a column of magma